Okay, things are changing with time still because I see per second, right? Here we go. So I've got this equation. So I'm kind of challenging you algebraically. This is the same thing as saying x cubed plus 1 to the 3 over 2 power, right? Because it's power over root, right? Over root. So it's a square root and a third power. Okay, so if I'm taking the derivative with respect to t, let me just kind of emphasize that for a second. And you don't have to write this, but just want to make sure you understand that this left-hand side is dy over dt. Here I'm going to do chain rule. So I'm going to bring the 3 halves down, carry the inside along, and subtract 1 from the exponent. Now I'm going to multiply by the derivative of the inside. So that's 3x squared times the derivative of x, which is dx over dt. Okay, so let's see what it gives me here. So that's they're telling me the y coordinate is increasing. Oh, so dy over dt is 2. Okay, and what is it I'm trying to find? I'm trying to find how fast the x coordinate is increasing. So find dx over dt. So it's necessary for us to find that when information. So I see when x equals 3. So I'm going to substitute in 2, right? 2 here for the dy over dt. Carry this along, and I'm going to be putting in x equals 3, right? So 3 cubed is 27 plus a 1, all to the 1/3 power. 3 times 3 squared is 9 times the dx over dt. Ugly numbers, right? That's all right. So let's see what we've got here. So this gives us 27. And so let's see, 2 equals 3 halves. So this gives us a 28 to the 1/3. I'm just going to leave it there. 27 times dx over dt. So I just need to multiply by the reciprocal, right? So I would get 4/3 if I multiply by 2/3. And then I'm going to divide by these two numbers. 28 to the 1/3 times 27 equals dx over dt. Totally ugly and totally acceptable. Do not spend time on your calculator because I know you know how to plug things in. You don't need to. This is a fine answer. Let's move on to the next one. Okay, a snowball is melting. So its surface area decreases. And I'm telling you what the surface area of a sphere, because it's a beautiful, perfect snowball in mathematics land. So the surface area, so that means dA over dt, it's getting smaller. So I have to assign it a negative value, -1. So then what the diameter, so find diameter changing when the diameter is 5. Okay, so let's see. My area equation does not have diameter, does it? It has radius. So I want to get d into this equation. So you know that radius is d over 2, right? So I'm going to substitute in a d over 2, and then I'll square it, right? D over 2 squared. And I'm going to suggest you simplify this before you take a derivative. Oh, will you look at that? My equation just turns out to be pi d squared. So now I'm ready to take the derivative. So I get dA over dt equals, carry the pi, take the derivative of d squared to d dd over dt, then I get to plug everything in. So dA over dt is -1, pi 2, and I'm plugging in d is 5, right? And d diameter over 2. So I would get -1 over 10 pi is how fast the diameter is changing. And let's remember, the snowball was shrinking, melting, right? So that means that diameter would be getting smaller as well. So having negative or positive answers has true meaning. Okay, so here we move into where you draw a picture for the problems. So we have a 10-foot ladder. So if it's a fixed amount, you're going to put that in the picture. So this is a fixed. Ladder is not changing length. Leans against a vertical wall. The bottom of the ladder is sliding away from the wall. So, and they tell us at the what rate. So don't put no rates in your picture because you want variables. Okay, so I'm going to label this X and say that my given rate is dx over dt, which is 1, because this letter X or this length X is growing at 1 foot per second. Okay, so what are they asking me for? How fast is the top of the ladder sliding down? So it's nice to put arrows so you understand what's happening. So I'm going to label this Y, and I want to find dy over dt. How fast is that changing? When information, they almost always use the word when. So when the bottom of the ladder is 6 feet from the wall, so when x is equal to 6. Be careful, don't use x as 6 in the picture yet. Save it until after the derivative. Okay, I think I'm ready for the equation. What is the equation? So I need an equation that matches the letter X and Y and uses my fixed number. You see it. 10 squared is X squared plus Y squared. Take the derivative with respect to t. Derivative of 10 squared is just 0. Don't be deceived. It's 2 times 10. This is 10 squared is a number. 2x dx over dt plus 2y. Oh, hold on a second. 2y dy over dt. Okay, so we're on to solving. I'm going to suggest we divide through by the 2, so less things to worry about. So let's see what I've got here. I'm going to plug in dx over dt is 1. X is 6, right? Put in x is 6, and it's all equal to 0. Whoops, plus I meant. I still have a y. dy over dt is what I'm trying to find, so that's okay that that's there. But I need to find out what y is, and we've done this. So you take x equals 6, and you put it into the original equation. Whoops, I'm not going to have enough room here. All right, put x equals 6 into x squared plus y squared equals 10 squared. So I get 36 plus y squared is 100. So y squared is 100 minus 36. So y squared is 64. So y is plus or minus 8. Okay, this case illustrates why in the past I was choosing the positive number. So I know that that distance y has to be a positive 8, correct? So taking this and solving for dy over dt, I'd get negative 6 over 8 is dy over dt. Does it make sense that it's negative? Is this length here? It is getting smaller. So the length y is getting smaller. That's why it's a negative rate.